Last we were talking about blockchains, and we're talking about blockchains originally. Then we jumped into SSI, self-sovereign identity, and solutions that do not necessarily need a blockchain-based stratum to work. Let us go back into blockchains, and let us go back into one thing that I mentioned in one of my slides. Blockchains originally were created to bring anonymity to the functioning, into their functioning. You do not need to be identifiable in order to use them. How truth is this? How much of truth is there in this statement? To answer that, we will have the next presentation now by Dr. Bernhard Haslhofer, who is going to talk about anonymity and identity identification in public blockchains. Currently, he's working as a senior scientist at the Complexity Science Hub in Vienna, where he leads the crypto finance research group. Previously, he was working for the Austrian Institute of Technology for 8 years. Now he's also the co-founder of Ignaio Crypto Asset Analytics GmbH. It is a pleasure to welcome you, Bernhard, once again. As it is, it should be there. Please use this mic. Yeah. Thank you, Sina. You know, yeah.
Have 25 minutes.
Yeah.
Try to.
Thank you very much.
Remain time.
It will
prevent people from having lunch.
Great. And you should now share the screen. It is this one. Fantastic. Configurarte. Super. Thank you very much.
Yeah, thanks, Claudia, for inviting me to this exciting event. I just learned a lot about SSI. Actually, I'm not an expert in this field. And when I was invited to this session, I was asking, okay, what can I contribute here? Because what I'm doing is I'm doing blockchain analytics. I'm doing this for 10 years now. And Claudia is completely right. I think we can learn a lot from what we are doing on public blockchains. And this could inform also the future design of e-identities, especially when it comes to anonymity, privacy, identification, etc. So, yes, that's the right button. So when we are talking about anonymity and identity identification and privacy and so on, what I have observed throughout the past decade is that we are in a tug of war game. So we have one side pulling for anonymity, and we have the other side pulling for more transparency. And both sides are doing this for very legitimate reasons. So anonymity, there is one obvious reason. Privacy is a fundamental right to everyone. And there is very good reasons to maintain, for instance, financial information as anonymous as possible. On the other side, we have illicit use of crypto assets. It's used for fraud. It's used for paying for child sexual abuse material. So it's there. And it's also at some point, we as a society agreed that we don't want to have this, and we have law enforcement that kind of tries to prevent this or mitigate and fight this. And they also need a certain degree of transparency to follow the trace of money to fight cybercrime. So we have the need for transparency, and we also have now the regulators jumping in, also demanding more transparency and traceability of funds, especially in the crypto assets context. So it's a game, and both sides are pulling strongly, I would say. And it's also, these goals are two naturally conflicting goals. So I would argue you cannot achieve both. So when I read a paper saying we have a completely transparent, privacy preserving blockchain, it's like, okay, probably a paper that won't make it. Yeah, but before we go into the details and I explain what this means in the context of public blockchains, we should talk a little bit about anonymity, what it actually means, because I think there is also quite a bit of misunderstanding there. So for us, and I'm a computer scientist, anonymity is essentially the combination of pseudo-anonymity plus unlinkability. So this is the easy equation, which means if I have an anonymous system, it should not be possible to link users or pseudonyms of the same users. So here in this example, the blue user has a pseudonym, and it should not possible to link the pseudonym to the user, and it should also not be possible to link pseudonyms with each other, which can then be linked to the user. So this is what we understand when we talk about anonymity. And in computer science, there is sort of an agreement that complete anonymity is really hard to achieve. This is also why we always talk about degrees of anonymity or anonymity sets. And an anonymity set is just let's say a set in which contains entities that cannot be distinguished anymore. And the way how you create an anonymity set is by stripping off the features that allow you to connect the data points. So this is what we do in computer science. We kind of agree that full anonymity is really hard to achieve, and the best you can achieve is anonymity set. And the larger the anonymity set is, the higher the degree of anonymity is. So this is what you have in computer science, and this is also what you see when you work with privacy-preserving wallets, like Wasabi, for instance, that you can configure the anonymity set you would like to be. The higher it is, the better is the privacy you have. Okay, I think nowadays most people know that Bitcoin is not anonymous anymore, but I still see papers starting with the sentence, Bitcoin is a decentralized anonymous currency. That's usually also one reason to not directly accept the paper, because it's really clear nowadays that this is not the case. It's neither anonymous nor really decentralized. But why is this the case? Because in Bitcoin, and actually also in most other crypto assets, we have a lot of public information we can access. We have all the addresses in the blockchain. These are in fact pseudonyms. And we can also access all the transactions that have ever taken place. So we have a fully transparent environment, and we can use the data there. We can also use algorithmic methods, so-called clustering heuristics, to cluster those addresses, which are in fact pseudonyms, together. So we can link them. This is done by clustering heuristics. And since in crypto asset ecosystems, in the larger context, we also have virtual asset service providers that store personally identifiable information. It's also possible to link personal identifiable information with addresses. So what is the consequence when we look into Bitcoin? If we take the previous equation and say anonymity is pseudonymity plus unlinkability, it's pretty clear nowadays that this property of unlinkability is simply not given. And for this reason, nowadays, when you write a paper about Bitcoin, you should open, in the introduction, you should say, Bitcoin is a pseudo-anonymous cryptocurrency. So this is the state of the art. And why is this the case? Because things are linkable to a large extent. What is the consequence? Yeah, all the data is available. The data points can be linked. And as a consequence, all financial transactions are tracked and traceable. Okay. So you can basically follow the money. You can see how the money flows in this ecosystem, which is good for us as scientists, because we can also analyze those blockchain-based ecosystems. It's fantastic because it's the first time ever that you have full access to, let's say, a financial ecosystem, which we don't have in the traditional fiat sector, and we can learn a lot. So it's a social science laboratory for social scientists, for economists, for computer science. It's perfect. But of course, it also has implication in other areas. Okay, you might know that there are also tools available that just focus on doing this. You have commercial tools, and I just listed the leading commercial providers. We also have open source tools. There's BlockSci, which is a Python library that allows you to exactly do this, take all the data from a public blockchain like Bitcoin and analyze transactions. GraphSense is our open source development. We've been building this platform for several years. Having a scientific motivation as a background, because what we do is we do studies, we study crypto asset ecosystems, and of course we use the data to infer all sorts of findings from data. And what we recently started is, let's say, transition a little bit from the open source spectrum also into the commercial sector by offering our crypto asset analytics platform also as a commercial service, because it seems that there is a lot of demand there at the moment. Just to give you an impression how this looks like in practice. So some of you might be familiar with commercial tools, and I'm just showing you ours. But if I would like to know something about a Bitcoin address, and this is in fact a Bitcoin address that was involved in some fraudulent activity, specifically in some sextortion spam attack, just by accessing the publicly available data in the blockchain, in this public blockchain, I can infer a lot of information. I see exactly all the incoming transactions. I see all the outgoing transactions. I know exactly how much money this single address has received. And I can use clustering techniques to also find all the other addresses, most likely controlled by the same actor, can infer how the actor controlling all those addresses, how much money he most likely received. Then I can go on the incoming side and have a look, okay, those who were victims of this attack, where did they have their wallets? So the address I'm showing here is actually an address controlled by a perpetrator. And of course, the perpetrator collects money from victims. So what you can do is you can look at the incoming side and you see, okay, these are the virtual asset service providers where the victims opened the wallets in order to send basically extortion funds to the perpetrator. So this is possible, and this is all possible because of those clustering techniques. And you can really pinpoint also the individual transactions the user executed in order to pay those funds to the perpetrator. And then this is usually what law enforcement does. You can also look where the money went. So what law enforcement typically does is they want to know where those digital funds enter the real world fiat system again. And this is typically done at some exchange or with virtual asset service provider. And what we see here is that the perpetrator obviously applied some standard money laundering techniques, so split the money in different addresses. But of course, if you have the technical capabilities and the knowledge to do this, you can easily search this graph and you find all those entities where the money resulting from this criminal activity left the crypto asset ecosystem and went back into the fiat system. So this is just an example. I think I'm killing myself with this. Okay. Yeah, so this is how all those platforms work. And this is our platform we are using for our research mostly in order to produce our papers. Okay, so this is the state of the art. So this is what can be done by just accessing the public information on blockchains and combining it with additional attribution data, which you can gather from different sources. Of course, we also have the other side in the tag war game that tries to increase privacy, so make traceability harder. And there are two main mechanisms you can use nowadays. The first one being coin mixing and the other one being privacy coins. In coin mixing, you have different options. In the past, people used central mixing services, which are just basically shuffling coins of users so that the outside observer doesn't know anymore who owns a coin. The downside of those central mixing services was that sometimes they were run by criminals and you were never sure if you really got your coins back. Nowadays, the state of the art is actually to use decentralized coin joins, and the most famous wallets that are out nowadays are Wasabi and Samurai. So if you would like to remain private, you can either download Wasabi on your desktop or download Samurai on your mobile wallet. And you can use this basically to mix your transactions and your coins with coins of other users, which makes it really hard for outside observers to know who was sending money to whom. Okay, so this is something you can do, but as we show in one of our paper, which will be presented in September at AFT, and which will appear as a preprint in the next days, I promise, is it is possible to pinpoint those transactions. So by just looking at the blockchain, I can come up with an algorithm that shows me exactly, okay, this transaction was a Wasabi transaction, this transaction was a Samurai transaction. And we were just curious to what extent these services are actually used. So to how large this demand for privacy actually is by the users. And what I did is I just played around with those mixing service wallets and just sent money from one exchange back to my Wasabi wallet, then to the next exchange, back to my Wasabi wallet. And what I found is no one ever asked me why I'm basically using such a service, which could also be abused, of course, for money laundering purposes. So I was never asked while doing this. So we were also curious how much money actually goes directly or indirectly into exchanges, because this has some implications if you think about current regulatory efforts on the European level. Anyway, so what we did is we came up with an algorithm that allows us to pinpoint those transactions. So we know exactly which transactions are coin mixing transaction with an accuracy of more than 99%. And what we also did is we quantified how much money is actually tunneled through those wallets and found a lower bound of $4.75 billion US, which means it's something, right? It's not nothing. There seems to be a need for privacy for very good reasons or bad reasons. We don't know. We were also quantifying what's the monthly throughput, and for Wasabi this is roughly 172 million. For Samurai it's a little bit less. We were also interested in how much money actually goes directly from such a privacy-preserving wallet to an exchange. And we found 322 million as a lower bound. And if we just go one hop out, we found roughly 1.16 billion US dollars. Why is this important? If you just follow the discussions that are currently going on, about the travel rule agreement, for instance, there was this discussion, should an exchange be required to know where the money is coming from, also from unhosted wallets? And because traceability of funds is kind of important if you would like to prevent anti-money laundering. And yeah, what we see is that there are quite some funds going directly into exchanges. I don't know if questions are asked. Okay, the second privacy technique one can use is Monero, which is just an example for a privacy coin. And what Monero does in contrast to Bitcoin is it really makes it hard to link data points. So in Monero, it's not clear which one is the right previous output. In Monero, it doesn't show me any value. And in Monero, it also doesn't reuse any addresses as it's done in Bitcoin. So it's really hard to link data points in Monero. And interestingly, in science, and we basically came up with the same finding in one of our papers, we say Monero transactions are really not linkable and therefore untraceable with passive blockchain analytics methods. So, but just looking at the data, those public available data, it's not possible to effectively link and de-anonymize Monero transactions. So this is what science says. Then we have industry, which says something else. And there are two players at the moment who say that Monero transactions are actually largely traceable. So I recently heard the number 60%, which is interesting for us because it kind of contradicts our findings. Honestly, I don't know how it's done, also because the methods are not disclosed. It's a black box, even though it's patented in one case. The only way I can imagine how this works is by using an active attack. So by controlling a large fraction of all transactions that we're executing, then I can just eliminate possible candidates and basically make the linking much easier. So this is how I imagine it could work. But just with private or with passive blockchain analytics attacks, it's not possible, at least to the best of our knowledge, to really link and de-anonymize crypto asset transactions in public blockchains. Okay, so coin mixing and privacy coins are two techniques to make traceability hard. How can we make traceability even harder? And there is one current development that's really causing headaches to everyone working in the field, and that's the development of decentralized finance. So you might have heard about this decentralized finance. It's really the idea of providing financial services implemented as smart contracts on top of distributed ledgers, most importantly Ethereum. And you have services for taking loans. You have services for wrapping assets from one chain to the other. You have derivatives like options, futures, whatever. And you also have, most importantly, decentralized exchanges, which are basically doing what virtual asset service providers or exchanges do, just in a decentralized fashion. And the problem, so it's not so much a technical problem, this non-traceability or the current non-traceability of DeFi, it's more a problem of complexity. The problem is that a DeFi protocol, it's essentially an application written in a programming language that consists of usually several or many smart contracts that are doing something. And this doing something is really hard to understand because usually only the developer really understands what the program is really doing. You can, as an outside observer, try to reverse engineer what it's doing. But given the complexity of those protocols, this is really hard. And here on this plot, you just see all the smart contracts that are involved in Uniswap, which is one DeFi application, which is one decentralized exchange application. I mean, of course, there are many contracts that do the same, but it's non-trivial. Furthermore, it's also possible to compose DeFi applications. So you could take a lending service and another DEX service and combine this and create yet another financial product out of this. So what you're doing is you might provide additional financial functionality, but what you're also doing is you're combining complexity with another complexity and build an even more complex construct that's really hard to understand. So technically, all the data is there. It's not just the blockchain data, it's not just the transaction data on the Ethereum blockchain, it's also really the logs produced by those programs that you have to understand, but it's really hard. It's technically challenging to just understand what's going on in DeFi. So I would say, I'm not sure if I'm allowed to say this here, but if you really would like to effectively launder money, go through DeFi. So it's also done already. So if you look at recent reports from major tool providers, they all say, okay, DeFi is the new way to go for laundering criminal proceeds. Okay, going back to the beginning of my talk, to this tug of war game. So my hypothesis is that this game will continue forever. So you have researchers making sure that privacy is increased and it's harder to basically link and de-anonymize the data that is available on a blockchain. On the other side, you have other researchers doing the opposite. So it is and will probably remain a tug of war game. But what are the implications? What are the implications for those asking for more transparency? So first of all, I think it must be clear that privacy and anonymity in blockchain-based systems, especially in public ones, is much worse than in traditional banking. So if someone claims that public blockchains improve the privacy problem of the traditional banking sector, please just think twice when saying this. I would even argue, if you combine blockchain data, transaction data, with the data points available in a virtual asset service provider, and there are not that many globally, what you have is actually a financial privacy dystopia. So it would be a nightmare from a privacy perspective. And this can easily happen. Just think about the possibility of a WASP being hacked or a government intervening in getting the data. So what are the implications when using those techniques? Be really careful, be aware that it's super sensitive. It could actually become an effective surveillance system. Really try not to collect and link personally identifiable information directly with the data on the chain. I mean, there's always the possibility to do it indirectly and have a court order in between. So this is how it's done in our environments. Follow privacy by design mechanisms, just collect the minimal amount of data needed. And I think what's also very important, be transparent and avoid black boxes when you applying those techniques. What are the implications for the other side, the side pulling for more anonymity? Be aware that complete anonymity is simply hard to achieve. It's really hard to ever claim that a system achieves full anonymity, full privacy. This is, I would say, almost impossible. And then the two recommendations I can give you, this is actually not rocket science, but more common sense. Yeah, do not share any sensitive data with parties you don't trust. I think this could be interesting in a private blockchain setting, because there, by definition, you build a system with parties you don't trust. But if you don't trust them, think twice what data you put on the blockchain, because if you take a blockchain analytics guy, I mean, you can always infer a lot of information just by looking at data points and linking them. And yeah, I mean, it's obvious, right? Do not put any privacy sensitive data on a blockchain, not in a public, not in a private setting, not in a how's it called, permissionless and permission setting. So this is my recommendation. I know it's not rocket science, it's more common sense, but hopefully an input for the digital identity discussion.
Fantastic. Thank you very much.
Hello. Hi, thanks. It was very, very interesting. Now, when it comes to anonymity, we often conflate accounts with public keys, right? Mm-hmm. And this alone creates, we could say, a single point of failure, right? Because once you crack it, then you can follow everything that ever happened, right? So I work on a new layer 1 public chain for smart contracts. And one very simple thing we did is to simply dissociate both. So accounts are effectively separate entities that are linked dynamically to public keys, but you can always switch the public key, right? And that's a legit feature, because that allows you, for instance, to rotate your key without having to create a new account and transfer your assets and so on. But the neat side effect is that even though technically speaking, it's still pseudo-anonymous, what kind of guarantees do I have from an analytical point of view that when you change your public key, it's still you, right? Isn't it a simple way of kind of breaking my ability to trace you? Because I don't know who it is now.
So I'm not sure if I fully understand the question, but I think what you're doing goes roughly in the direction what Monero is doing as well, right? Just prevent that you're reusing the same public key again and again, which would enable traceability, right? Is this
well, as an end user, you can always change it if you want. You don't have to, but you can.
Yeah,
right? I
think the major issue you will face is that end users are usually lazy and will never change the keys and just reuse what they have. This is also what we see in Bitcoin. This is also why law enforcement is still successful, because also the criminals who are usually smart enough, they just don't care. And I think, I mean, the big problem we have across all those topics is the problem of key management, and that the user needs the capability of the skills and the capabilities of handling his keys or her keys. And I think that's the big challenge, and that's a non-technical challenge. Yeah. Yeah. This is exactly what we're doing. We're just following the recommendation by Nakamoto.
Yeah. Thank you for your presentation. Well, concerning this question, I think changing keys every time. And some wallets do it, but it's not sufficient to create anonymity. Of course not. And we have the financial regulation that is actually making anonymity harder by providing and asking more information. So they prevent us from privacy. It's on purpose, of course, and in the traditional system, there is no privacy for regulators, but for the rest of the world. Concerning anonymity, I found your definition interesting. It is, of course, a different definition than we find in the law. You don't need pseudonymous unlinkable data to create anonymity, but everything that is unlinkable and doesn't contain any information that can be linked to a person is anonymous. It doesn't have to come from a pseudonym that cannot be linked anymore. So you have perfectly anonymous data, like the size of the Earth. This is not personal data. So this is also possible. So if you go back, take a step back from individual accounts that you try to anonymize, but you just have anonymous information that does not link to a single person that you cannot identify, but that does not just not link to a person, but to something else, then you're getting closer to anonymity.
Yeah. So if I have data points that are not at all related to the other data on a chain, then it's probably unlinkable, right? Or
sure, if you have aggregated data,
Yeah.
or if you have a mass transaction and etc., then you're not having single data points. So if you give up the concept of single data points, you get closer to anonymity.
Yeah. And the question is, I mean, I agree. Yeah.
Well, I found it's a great presentation, and one question is, you can also use non-public information for analysis. So, for example, you can trace the IP addresses of where the transaction comes from if you do an internet trace, and then you can see with a higher probability from which IP address this transaction has originally been sent, and then you're getting even closer to.
Yeah. So this is a very good question. So if you just look at the blockchains, you don't have IP addresses, but at least at the very beginning of Bitcoin, it was possible to just run nodes all over the world and then collect all the traffic and do triangulation, and you could infer IP addresses of transactions. Honestly, I'm not sure if this is possible anymore. I don't think so. But what we have shown in one of our papers is by just linking to other systems. So what we did is we linked to the Lightning Network. What we could show is that you can link clusters in Bitcoin, so clusters of addresses in Bitcoin, to nodes in the Lightning Network. You can make a direct link. And of course, there you have IP addresses, and you could basically infer then that a cluster of Bitcoin addresses also carries those IP addresses. So there are, by just combining those data with external data sets, you can enrich them as much as you want.
You can also use internet surveillance data for that.
You could, yeah.
If you have it, of course.
You could. This is what I'm saying. It's you can do a lot, but you have to be careful in what you're doing.
here on the audience, while I one of the numbers there were 1.4 billion USD traded through the
Good question, which of course I don't know from the top of my head. But it's a very good question because
I want to see which is the range.
the relative, you should look at the relative amounts, yeah.
Thank you.
But I don't know the number.
We will see in a few minutes. Thank you.
Thank you for the great question, great presentation. And then actually I'm a financial regulator, and then I'm in charge of part of virtual asset conduct group. So we are developing travel rule and then as a regulatory framework for AML safety. And then I guess many of you hate part of because we invade privacy of individual users. But what we want is not to expose privacy of individual users, but to mitigate the risk of money laundering and terrorism financing. So what we can do right now is just to store privacy information of virtual asset service providers by sharing sender and then beneficiary information. But we are always looking for an alternative solution to balance the privacy and then risk mitigation. So this is a kind of open question, but what do you think about the future or alternative method of achieving our goals?
So you're asking me about regulatory questions, and I always try to stay away from this as much as I can, honestly, because I'm not sure if I'm the right person to answer this. And I have two hats as well. I mean, from a pure forensic perspective, you would like to have as much information as possible. That's clear. But from a privacy perspective, you would like to have the opposite. So I think the big challenge is really to find this middle ground and this tug of war game. And it will always shift. And when major incidents happen, it will shift more to the transparency side. I mean, just as we've seen with DeFi now, I mean, I guess regulators have to do something about this, right? You cannot just let it happen. And if things go well, it will probably shift to the other side again. I think it's really hard to answer. And I think I'm not the person who should give recommendations on the regulation. But it's an interesting question.
Thank you very much.
Thank you. Shinichiro, I think. Yes, exactly. So then, thank you very much. Bernhard, but you have to stay because we will now join the panel. We will have a shorter panel, but Shinichiro is going to lead it. Thank you very much once again for your presentation.